This week we are picking back up on the Learn You Node tutorials. We've been working through the exercises slowly but surely, and in this video we'll go through maybe one or two more. Let's get started. I'm going to start by typing the Learn You Node command, and we will take a look at our next exercise, which is an HTTP client. Create a file named http-client.js. Write a program that performs an HTTP GET request to a URL provided to you as the first command line argument. Write the string contents of each data event from the response to a new line on the console. Just taking a quick peek at the hints, it says for this exercise we will need to use the HTTP core module. That might be all we need to get started with this one. Switching over to code, I've currently got my sidebar open, which is great because I need to create a new file, and it's http-client.js, I think. Let's double check. Yes. Okay, now I'm going to close out my sidebar. Command B on my Mac. I know I need the HTTP module, so I'm going to go ahead and require that. Just like this. I'm also going to switch over to Chrome and jump into the documentation here. Here's HTTP. Now we'll switch back over to code. I want to pull the first argument, which is going to be the URL that we're making the request to. I get that from process.argv. And the first argument is going to be index 2. Now let's go back to the documentation. I need to find a method that will let me make a request. It looks like there is a client request class. There might be a simpler way though. Let me keep going here. Okay, right on the module there is a get method, which I assume will make a get request, and that's what we want to do. It has two different signatures I can use. I can either pass in an options object as the first argument and then a callback, or I can pass in a URL as a string or a URL object, and then optionally I can pass in options on top of that and then an optional callback as well. When a method has two different signatures like this, and just to be clear, the signature is the arguments the method takes. When a method has two different signatures, it means we can just pick which one we want to use. I kind of like the second one better because it definitely needs the URL. You can't really have a GET request without a URL, so we have to have that. It may or may not need additional options, so let's use this second signature. We'll pass the URL as the first argument. If we need to pass options, we'll pass them, and then we'll pass a callback, which we probably will need because we need to do something with the result. Here's an example of fetching some JSON. They have also used the second signature. They've passed a URL string as the first argument, and then they're passing a callback. So this one does not have the options object. Let's flip back over to code, and we can start writing that. http.get. URL is the first argument. And then we're going to get a result back. Let's flip back over to that documentation. The callback is invoked with a single argument that is an instance of http.incomingMessage. I'm going to open that documentation in a new tab so that I can flip back and forth and see exactly what I am getting back here. I'm getting back an object that is an instance of this class. It has some events. It has some properties. It has methods. One thing I'm noticing about this incoming message that's a little bit curious is that it only has 2 events documented. It's got an aborted event and a close event. I believe the instructions for the exercise said we should listen for a data event. Let me switch back over. Yeah, it says write the string contents of each data event from the response to a new line on the console. The response is an instance of this incoming message class, so I would expect it to have a data event, unless one other thing I'm noticing here is that this incoming message class extends stream.readable. That means it inherits every property, event, and method that stream.readable has. So it's entirely possible that stream.readable has a data event. Let's look at it and see. It does. Here's the documentation for that event. Okay, now this is starting to come together for me. I'm going to switch back over to code. I'm going to call this response. It's pretty common to name a response res, but I don't see the point. I'd rather just spell it out. That way we don't have to remember that res means response. What do we want to do in the callback? We need to be listening for data events on the response. To do that, I use response.on, and then I pass in a string that is the event I want to listen for. In this case, that's going to be data. Now I need to pass another callback here, and this callback is going to be the callback that handles the data event. Let me actually bring up this stream readable documentation in another window so that we can see it as well. The data event calls the callback and passes in a chunk, which is a chunk of data that's coming through. Here's an example down here of how you would implement a listener for data. Let's flip back over to our callback, and we'll just call this chunk. Need to fix my indentation here. Okay. Let's go back to Learn New Node. What do we want to do with each chunk? Write the string contents of each data event from the response to a new line on the console. I know that if we just log out a string, each time we do that, it gets written on a new line. So I don't think we'll have to do anything special to get these on a new line. We should just be able to log out the chunk, assuming the chunk is a string. This is simple enough. I think the best way to test that is just to try it. Now we will flip over to the terminal. I'm going to run this interactively myself. What's it called? HTTP client. And now I'm passing a URL. Let's just go for google.com. Okay, invalid protocol, HTTPS not supported. The HTTP library apparently doesn't support HTTPS at all. Okay, that sort of worked. That wrote out a buffer. I remember from before when we were working with buffers that the buffer has a toString method. So I think I could just call that on the chunk before I log it out in order to log out a string. Let's try that. Yeah, okay, that looks good. I got a 301. That's because Google is going to redirect me. Oh, okay, I think it's redirecting me to www.google.com. Let's just try fetching that and see what happens. Okay, yeah, this is the HTML that comes back when you fetch Google. And it's mostly JavaScript. But this is the page that comes back. It looks to me like that works. I want to run it through the Learn New Node verifier. Looks like we have a pass. Submission results match expected. Your solution has passed. And here's the official solution. Let's see how that compares. It's very similar, even though a lot of it looks kind of different. They've required the HTTP core module just the same. They're doing the GET request the same, although they're passing the argument directly into it instead of breaking that out into a separate variable. They've written the function as a function declaration, I think is what this format is called. I always get those mixed up. And then instead of calling the toString method of the response, they are calling this setEncoding method and passing in UTF-8. And I'm pretty sure what that's going to do is that's going to make all of their chunks that come back on the data event strings by default so that they don't have to be converted. Which is why instead of writing a separate anonymous function to pass in as the callback for their data handler, they can just pass in console.log because all they want to do is they want to pass that chunk, which is now a string, directly into console.log and log it out. A couple of other things they've done here. They've done error handling, which wasn't mentioned in the spec for the exercise, but it is a good practice. They've handled an error on the response and logged it out using console.error. They have also handled an error on the get call and done basically the same thing to it. Let's go to our next exercise. HTTP collect. Create a file named http:/collect.js. Write a program that performs an HTTP GET request to a URL provided to you as the first command line argument. Collect all data from the server, not just the first data event, and then write 2 lines to the console. The first line you write should be just an integer representing the number of characters received from the server. The second line should contain the complete string of characters sent by the server. This is interesting. One thing that I'm not sure about based on this description, it sounds to me like they're wanting the second line to have all characters. I don't know if that means we need to remove any new line characters, or if new line characters can also go on the second line, which then makes it more than just the second line. That seems a little ambiguous to me. Let's read on and maybe the hints will tell us something that will help with that. 2 approaches you can take to this problem. Collect data across multiple data events and append the results together prior to printing output. Use the end event to determine when the stream is finished and you can write the output. Or use a third-party package to abstract the difficulties involved in collecting an entire stream of data. Two different packages provide a useful API for solving this problem. Buffer list and concat stream, take your pick. I think that second option introduces some complexities that maybe we don't want to deal with right now. I could get into the first one and find out that it's actually more complex, but I think I want to try that one first and just see how difficult it is to implement. If it gets too difficult, we'll come back and maybe pull in one of those third-party libraries to help. I'm going to flip back over to code. This is similar to the last solution. So I will start by duplicating it. And what is the name they want? http collect.js. Let's try that again. http collect. Okay. That will give us a starting point. I'm going to go ahead, before I forget, they said to listen for the end event. And this callback apparently does not get anything passed into it, which makes sense. I'll leave this blank for now, and we'll come back and fill that in later. I liked their set encoding approach. Let's do that so that we don't have to convert everything to a string. UTF-8, I think that's right. Oh, actually, I've done this in the wrong place. That doesn't get called on the chunk. That gets called on the response. I need to collect all of these chunks into a single string. In order to do that, I'm going to create a string here, and I need to declare it with let, because it is not a constant. I'm going to be changing it. I'll call it all response characters. And I'm going to set it to an empty string. I'm not sure if I have to do this, but I think I might, and I'll tell you why in a moment. Now instead of logging the chunk, and I also don't need to call the toString method because it's already a string, so let's just ditch this whole line. What I'm going to do with it is I'm going to take all response characters and then plus equals the chunk. Plus equals, if you haven't used that assignment operator, what it does is it appends or adds depending on the type of variable, and I think it's depending on the type of variable on the left side, which is why I went ahead and set that all response characters to an empty string. That way it was already a string. So plus equals, depending on what's on the left side, will either add, concatenate, whatever's appropriate to that variable type. For a string, it will concatenate and set the value of what's on the left side to the concatenated value. So this is going to be all response characters plus chunk, and that's going to be the new value of all response characters. We'll do that every time there's a data event. Then, when we hit this end event, what does it want us to do? The first line we write should be an integer representing the number of characters. Okay, that's pretty easy. That's going to be the length of the string, and the string is all response characters. Length. Fix my indentation. Okay. And the second line is going to be the accumulated characters. I think that may be the solution. Let's try it. And again, let's try http www.google.com. Okay, this is our extended second line. And the first line is 48,002. That seems reasonable. Let's try the verifier. Looks like we passed. Let's see what the actual and expected values were. This is their count. This is the second line. And then I guess this was another test maybe. Here's their official solution. Let's take a look at that. This one is going to be a bit different from ours because they've pulled in this BL library they mentioned before. They are calling a pipe method on the response and then passing in the BL module, which is apparently a function, and they're calling that and passing in some sort of callback function. What does that pipe method do on the response? Let's see if we can find that. I wonder if that is a readable. Yeah, that's a method of readable. The readable pipe method attaches a writable stream to the readable, causing it to switch automatically into flowing mode and push all of its data to the attached writable. It sort of binds a readable and a writable together, so I'm assuming calling that BL method and passing in this function creates a writable. Not being super familiar with BL, it's hard for me to reason much further than that about exactly what this does without really digging in deep. But I will say, I think our solution is a lot simpler and easier to understand. I could understand using this if you had to do something that became really complex. But I think for something simple like this, I think we did the right thing. Let's see what's next. These are really quick. Juggling async. It's my favorite thing to do in JavaScript. Create a file named jugglingAsync.js. This problem is the same as the previous problem, HTTP collect, in that you need to use HTTP get. However, this time you will be provided with 3 URLs as the first 3 command line arguments. You must collect the complete content provided to you by each of the URLs and print it to the console. You don't need to print out the length, just the data as a string, 1 line per URL. The catch is that you must print them out in the same order as the URLs are provided to you as command line arguments. I'm going to again duplicate this HTTP collect solution to the last problem. Juggling async, is that what it's supposed to be called? Yeah, juggling async. Okay. Now we are getting 3 URLs, so we need to grab all of them. I'll just call them URL 1, 2, and 3. If we knew more about what these 3 are, and this is all sort of contrived, so there's not really a reason you're getting 3, except that's what the challenge says. But if we knew more about them, I'd try to come up with better names for them. For the purposes of this exercise, I think URL 1, 2, and 3 are fine. Let's flip back over and read the hints. I'm not actually sure the best way to approach this. Don't expect the 3 servers to play nicely. They're not going to give you the complete responses in the order you hope, so you can't naively just print out the output as you get it, because they will be out of order. That makes sense. That's probably not what we'd want to do anyway, because you can never depend on those sorts of async tasks to happen in order. You will need to queue the results and keep track of how many of the URLs have returned their entire contents. Once you have them all, you can print the data to the console. Okay, that makes sense. What I'm going to do here is I'm going to initialize 3 variables, response1, response2, and response3. I'm initializing these with the let keyword because we're going to fill them later once those responses come back. In this first get, we're going to get URL1. I don't need this all response characters anymore because I've already got variables for each response. I do think I should probably initialize all these to an empty string just to be sure my plus equals assignment operator will work properly. Now I will change this on the left side of that plus equals assignment operator to response1. On end, instead of logging it out, I can't do that because that doesn't happen until everything is back. I am tempted to come here and say if response1 and response2 and response3, and only then log them out in order, but I don't think this will work properly, and here's why. Since we're adding data to the response variables as the chunks come in, there could be, and very likely will be, a point where one of these ends and the others have some of the response in them, but not the entire response. So if this is all we did to determine if all the responses were in and printed or logged to the console, then we could very easily log before they're all completed, when they all have some data but not all the data. I'm also tempted to come up here and say, not const, but let response1 finished equals false, response2 finished equals false, and response3 finished equals false. Then on end, I could just change that value and test for all of them to be true. That would work, and I think what I'm going to do is similar to that, but my variables are sort of becoming a mess here. I don't like how this is evolving. So what I'm going to do instead is I'm going to make an object to hold all of these. I'll call it responses. And I'm just going to make the keys the number of the response. We'll call this body. And that will be an empty string. We'll call this finished, and that will be false to begin with. Now I just need 2 more of these. This one will be 2, and this one will be 3. Now I no longer need these variables. This can be responses.one.body plus equals chunk. On end, the first thing I'm going to do is I'll set responses.one.finished equals true. And here I can say if responses.one.finished and responses.two.finished and responses.three.finished. If all those are true, then I can log each one out. Responses.one.body. And I'll copy this a couple times for the other 2. I can get rid of this log on line 32. No longer need to do that. Now I can duplicate this for the other 2 URLs. I could do a find replace here, but I don't know that it's worth the effort since there are only a couple things to change. I think that should do it. What this is going to do is when the script starts running, it's going to kick off a GET request to each of these three URLs. It will start accumulating the data as it comes back into this object, the responses object we set up. When a response is finished on this end event listener, it's going to set that response key's finished key to true, and it's going to check to see if all of the finished keys are true. Once all of them are true, it's going to log out all of the bodies in order. I am noticing that my linter doesn't like this, doesn't like the one in this dot notation with the object. I suspect maybe JavaScript needs that a different way. Maybe like this, which is another way that you can reference a key in an object. And I suspect for numeric keys, we will have to reference it that way. I'm going to go through and do that really quickly. Okay, that's better. Looks like I may have also left a dot out here. Okay, I think we're good now. There are a number of problems with this code, and I will come back and tell you about those in just a minute. First, I want to see if it works. I don't think I want to test this interactively because we're just going to get a ton of output and it's going to be hard to make any sense of it. You saw how many characters we got back just from Google, so if we try to fetch 3 different URLs, it's just going to flood our terminal. Let's just run the verifier instead. It looks like we passed. Now let's flip back over and talk about why you probably wouldn't want to do it that way. The biggest problem is that we have a bunch of repeated code. Basically, everything here in this HTTP GET call is duplicated 2 other times. That's not necessarily a bad thing, but also it's probably not necessary. And if you do this a lot, it can become a real problem when you go to maintain your code. Let's just imagine we found a bug somewhere in this code. We would have to change it where we find it, and then we would also have to go through to each of these other instances and change it there. That's not super hard here because they're back to back and there are only 3 of them. But imagine if you had 50 instances of this same code strewn throughout a gigantic file full of JavaScript. That could become increasingly painful to maintain later. So ideally, you wouldn't want to have that. This responses object may not have been the best solution either. We probably could have set this up as an array of objects. And let's just play around and see what that would have looked like. Something like this. Since I was using numbers for the keys in the response object, and since they were sequential, it probably makes more sense as an array. Actually, the other thing that will change is these are now actual numbers and they're 0 indexed. So it would almost be the same, but not quite. So this would be 1, and this would be 2. And these are numbers. The keys were strings, so they had to be referenced that way. But now the indexes are numbers, and they're 0 indexed. So it'd be something like this, and then I'd make that same change on down through the rest of the file. That's probably a better fit for responses. One other thing I wanted to point out that you may have noticed, this responses is a constant and was previously as an object, even though we are going back and making changes to it after we declared it. That's because you can assign an array or an object to a constant and still change the contents of that array or object as long as you don't try to reassign the whole variable. This will work. I can add to the array, I can remove items from the array, I can change individual objects in the array, and I'll have no problems, even though it's a constant. If I go and say responses equals something, anything, then JavaScript is going to flip out because this was declared as a constant, which means it can't be reassigned. It can be changed, though. In some cases, like with a string or a number, it can't really be changed because in order to change it, you have to reassign. In cases like a string or a number constant, those cannot be changed because the way to change them is by reassigning them. And as far as my take on the debate over when to use const versus let, I will default to const unless I can't. So if I have a variable that I'm going to have to reassign later, I will use let. Otherwise, I use const. That way, if I have a variable that I didn't intend to reassign, but I am reassigning it, I will discover that earlier because JavaScript will throw an exception. Let's take a look at an alternative. The first thing I want to do is kind of restructure the data around the URLs that we're requesting and then the responses for those. Since those things are related, I think it makes sense to bundle them into objects together. You can see here that instead of a responses array, I've got a requests array, and that is changed to represent the fact that now the URLs and the responses are bundled up together in the objects. The first key in each object is the URL, and I'm still pulling those directly out of the arguments, just like we did before, except instead of having 3 separate variables to contain each of the URLs, they're now just part of those requests objects, which will eventually also contain the responses. This is the meat of the refactor. This is where we actually go in and dry up the code. DRY is an acronym. It stands for Don't Repeat Yourself. It's a best practice in any sort of software engineering, whether you're talking about web or desktop software, whatever the case may be. You generally don't want to be copying and pasting code throughout your own code base. You want to write it so that it's reusable so that you can use the same chunk of code in different places where you need the same functionality throughout your code base. Here's how we've achieved that with this code. Instead of repeating our HTTP GET call 3 separate times, once for each URL, we are iterating through that requests array we made earlier that contains the 3 different objects, which now will contain both the URLs and the responses. For each item in that array, we are then calling the http.get. That call is basically the same. We've changed a few of the names to accommodate the new structure of the requests object. So to get the URLs from the proper key in that object instead of getting them from those individualized variables. We were holding them in before. The responses are now in a different location. Two other things I did to get rid of some smaller repetition in the code. One, instead of checking each response individually to see if it had finished in the if statement, I'm using the array_every method, and I'm passing it a callback that returns the value of that request's finished attribute, which will either be true or false. The way the every array method works is if every response it gets back as it loops through that array is true, if one of the callback functions returns false, then every will also return false. So every is looping through this requests array. For each request in that array, it's returning request.finished. If that returns true in every case, that whole thing returns a true. So then all responses finished will be true. Then in our if statement, we can check all responses finished. Not only does that mean we don't have to check each one individually, but it makes our code a little bit more readable because now we're seeing the if statement that says if all responses finished. It's pretty apparent based on the naming what that does. If I'm saying if requests sub0 dot finished and requests sub1 dot finished and requests sub2 dot finished, that's just a little bit harder to read. It's a little messy. You have to keep some context in your head. You have to know that those three are all of the requests to really understand what's going on. So this is a cleaner solution. I've done something similar when I log out the responses. So instead of three separate log statements and just passing those three response bodies into them, I'm again iterating through the array with a for each, and my callback is just calling console.log and passing in that request's response body. With those three changes, we have a solution that doesn't repeat any code, but still accomplishes everything the exercise set out for us. All right, that's enough for this session. We will pick this back up and go through some more of the exercises in the next session. Please share your solutions in the comments below the video, and be sure to come back next time for more Node.js.